Welcome back to another LukeRS tutorial. This time we're going to do a platformer, and it's just going to be the platform controller in this case, mainly because quite a few of my students have looked at different platform tutorials, and there are loads of them out there for Godot. Lots of them really good, but a lot of them don't cover some of the things that they're wanting it to do. Now this one is going to be quite simple, and then I'm going to do another platform tutorial which is a bit more complex, which is going to have utilize some of these other animations in here, which is the hanging and the multiple attacks as well. So this one here, we're just going to get a basic attack in, we're going to get it running. I am going to have it jumping and also sliding in this case, which you could substitute for a roll as well. So there is a roll and a slide animation in this one. This is a really popular one. It's on itch.io. Just look up Animated Pixel Adventurer. It is free. You can throw the guy a few dollars if you decide you actually want to use this in something. But I'm just going to use it for demonstration purposes today. So I've got my Godot project here. I'm going to bring that sprite sheet in. I've got it open over here, so let's bring it into here. And just because this is a new project, I will set it to 2D pixel and import that. All right, so my scene, I'm going to build this all up in just one scene just to demonstrate things. So I'm just going to call this world, and we're going to get a test platform here. So I'm going to make a static body, and this static body is going to have a collision shape, and it's also going to have a sprite. Now, because I'm not too worried about what it looks like, I'm just going to put the texture there, and I'll pop that down here. Oops, no I won't. I'll pop it up here, and we'll set the collision shape to be a cube, a rectangle, and we'll make it fairly long. There we go, like that. And I'm not actually going to have a sprite. I'm just going to delete that. The reason for that is I will go visible collision shapes. Now I'm going to click this static body 2D and turn on that little bit there, so I'll move that over to here. All right, so there we've got our platform. We could have multiple platforms here so that we can demonstrate the roll and the jump. And I'll put one more in. There we go. All right, next thing is to create the character. So we're going to have a kinematic body for the character. Kinematic body, it's going to have a collision shape, and it's going to have a sprite, and it's also going to have an animation player. In future, in the next one, I will look at using an animation tree. Animation player. There we go, collision shape. All right, let's go ahead and with this sprite, bring the sprite in over here. And now, we don't want it like that. This looks like it's 1, 2, 3, 4, 5, 6, 7, and a bit sprites going across. So let's just check this out. It's kind of annoying that it's done that because it looks wider over this side. So I'm going to say that it's 8 across. So animation, H frames, 8. And it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 down. Okay, so if I zoom in on that, it should be all good. And we can just check the frames. Oh, no, it's going across that way. Let's turn it down to 7 and see. No, it goes that way. Well, that's useless. That. Okay. In this case, what I'm going to do is go to a website called Piskel. And I'm going to edit this sprite. And I'm doing this because I know that someone is going to have this same problem as me. So I'm going to import this. Maybe I can just drag it in. Yep. Import as a sprite sheet. The frame size. Let's see. I'm just going to check because I'm pretty sure I've got all the sprites here, and the individual sprites should all be the same size. They are. So let's have a look and see what size these are. This one is 50 by 37. So let's see if I import these, if it works. 50 by 37. Well, that actually did work. So I should be able to do that in there. So 1, 2, 3, 4, 5, 6, 7. No, actually, this is good here. Let's cut that right-hand side off. I'm going to import that, replace it. All good. Yep, that's all good. And then I will export it as a PNG and download this as a PNG. 9 columns, 13 rows. It's slightly different to what it was before, but I will now bring that back into my Godot project. So if I bring this back in here, and I'll need to change these settings here. So it was 9 and 13. Okay, now I can go through and test all those frames, and they're all centered and in the right place. So that's looking good. Okay, with that done, we want to get the collision shape sorted. So I'm going to go ahead and add in the capsule. I'll make that roughly the size of the character. Oops. And make it a little bit thinner and a little bit taller. That's pretty good there. Okay, so with that done, I'm going to go ahead and add in the animations. So the first animation I'm going to add is going to be idle. Now I'm not going to do all of the animations. I'm only going to do the ones that I need. The idle animation is going to be only a few frames long. I'm going to zoom in down here because I don't need, it's definitely not going to be longer than 1 second. So let's just go ahead and get it to about 0.1 for each chunk there. And I'll click on the sprite, and the first frame for idle is going to be this one. And it's kind of annoying that when it does this, it still stays at the first bit instead of going to the second. So I'll go to the second one and then keyframe this, and then keyframe it again, and then keyframe it again. All right, so here's my idle animation. If I change that down to 0.4 and then hit play, there's my idle animation. There's one frame in there that maybe shouldn't be there. Which one is it? I've done the first one twice, which was dumb. So I'll just delete that one and move those back and change it to 0.3. There we go, that'll do. I feel like I missed a frame there. Anyway, new, I'm going to use running. Okay, so let's go ahead, go to the sprite, find the first running animation. That's crouching. That looks like the first running one. We'll keyframe that. And then go to here. I'll just go back and make sure I'm on the first one. Yep. And keyframe that, and then I'll just keep keyframing it until we're done. All right, so there's that, and it's 0.6 long. So I can test that, hit play. That looks good. I'm going to do a rolling animation. And this one, I'm going to find the roll animation, or I could find the slide animation. I'll use slide for this one because it looks like that rolling animation is actually a jumping animation. So let's go ahead and keyframe this. I'll just rewind it back to there, and 2, 1, 2, 3. Okay, so that should do that. I don't want this one to loop. I just want it to kind of play once, and that's it. We could space it out a little bit longer, but this is going to be a pretty simple roll. It's just going to move a certain distance, and that's it. I could also keyframe the collision there as well, because that is quite large when he's on the ground sliding. I probably want to change the size of the sprite. But I'm not going to, because I'm just looking at getting the animations done here. So I've got running. Let me just think what else I need. I think I need a jump and a fall. So new, we're going to go jump. And I'm going to find the jump animation. That's a hanging animation. Okay, so this one here is the jump animation. It's not going to loop. I am just going to keyframe this here. Frame the first one, and then the second one there. Now let's see what this does. Oops. For some reason, those are the exact same sprites. So let's go ahead and keyframe that, then that. What I wanted to do is not really go between those two. I'm just going to have one frame for this. Different sprite sets, different things. So I just really want to have one frame for it for now. I could spend more time actually fixing it up and doing the jump or the loop bit. I'm not going to. And then fall is going to be my next animation, and that is going to be also 0.1 long. And I'm going to find the sprite for that, which will be after that. It's going to be that one, and I'll keyframe that and create it. All right, so I've got all these keyframes done, and the animations are in the animation player. They're all there, and there will also be an attack one. May as well make that now, actually. Attack. Let's find the first attack sprite. That's like a whole triple attack. That's a better idle animation there, but I'm just going to keyframe here. Let's go back one and keyframe. I may as well just do that. There we go. He's got a double attack. So that's going to be 1 second long. That's not going to loop. It will look like that. All right. I could make it a little bit longer, 1.2, and maybe keyframe the next one out. Okay, and then we don't want that last one there. All right, so I've got my animations here. I'm going to go ahead and add a script to this. I'm going to call it player controller or something similar to that. And we'll delete this we'll just delete all except for the bit at the top. All right, now I just need to bring up my other project over here. There are a few things we want to do right at the top here. So the first one is going to be export in var speed equals 120. I actually don't remember if I even used these because I wrote the code a few days ago. Jump speed, I'm pretty sure I do, equals -180, and then export var int var gravity equals 400. Now I've just got var velocity equals vector 2.0. Now I did base some of this code on Heartbeast's 1-bit pixel platformer, but it's so far from what that was that it's not really. There's just a few lines of code in here now that are similar to his, if you notice. So I'm going to export float. I don't think I actually use friction or acceleration. Oh no, I do. I think this bit here is from his pixel platformer, just this movement code. Friction equals 0.1, export float 1.0, bar acceleration equals 0.25. And then I'm going to create an enumerator. Now an enumerator is, I'll just build it up and kind of explain it as I go. So it starts with enum, then the name, I'm going to call it state. And then inside this here, an enumerator is kind of like a dictionary, except this word running, it actually has the value of 0. This word walking has the value of 1. This word has the value of 2. Rolling has the value of 3. Jump has the value of 4, and fall has the value of 5, except we don't want walking, so we'll delete that. Now what this means is that I can create a variable and it's of type state and assign it these values. It's just easier than doing it in a string, so saying player state equals string running, because the code will give me an error if I don't use one of these enumerators, and it's easier than remembering a number as well. So the next line is going to be var player state equals state.idle. So this is just saying, well, equals 1 in this case, but I might just swap those around. Not that it makes any difference whatsoever. So state.idle is the beginning state. Now we're going to write a little function here. This function is straight out of Heartbeast 1. I think I might change it as I go here. Var direction equals 0. If input, I'm going to write this different. And you'll recognize this from his stuff as well. Var dir equals input.get action strength UI right minus input.get action strength UI left. So there's our input. If direction is not equal to 0, I'll just show you the original code. The original code was, where is it? This here. So we've just reduced those 5 lines down to 1 line, which is going to give us this here. So to understand this, the action strength is going to be either 0 or 1. If you're pushing the key, it's 1. If you're not pushing the key, it's 0. If you're using like an analog controller, you can actually get kind of analog or like a fraction percentage, 0.1, 0.2, depending on how far along you're actually pushing it. Since we're using keys, it's either on or off. So it's going to be 0 or 1, take away 0 or 1. So the answer is going to be either 1, 0, or -1. That'll give us our direction. And so if the, let me just bring this back over. I can continue with that code. Here we go. I'll bring it over here. So if the direction is not equal to 0, then velocity.x equals lerp velocity.x direction times speed acceleration. So what this is going to do is it's going to take the existing velocity and it's going to calculate a number that is between the existing velocity and the direction. Okay, so if the direction is 1, we're going to calculate a velocity in between that. We're going to kind of accelerate. And then else velocity.x equals lerp. In this case, we're going to move it towards 0. Velocity.x we're going to move it towards 0. Friction. Okay, so that's going to slow it down by the friction amount. That's going to speed it up towards our direction, so 1 or -1 times 120 by the acceleration amount. In this case, it's 0.25, but it will do that very quickly. So it's going to do that every single frame. Okay, so now what we need is the physics process. Func underscore physics process. And we need delta in there. I know this video is going to be quite a bit longer than my usual ones. I may end up stopping it after we get this physics process done, and we'll look at adding the animation stuff in part 2. But this is going to be very simple. If player state is not equal state dot rolling and player state is not equal to state dot attack, then we're going to get the input. Now there's a reason why I've done it this way. And what's the error? No. Okay, so we do not want the player to be able to interrupt the attack or interrupt the rolling. So if the game is in either, if the player is in either of these states, we're not going to do this code. We're not going to get the input. And we're also not going to assign it movement and other stuff here. So if, and now this bit's a little bit tricky, and it's to do with how the movement code here works. But I'll print some stuff out so you can see what's actually happening here. What we'll do here is I'm just going to go if velocity.x equals 0, because this will make sense. So if velocity.x is equal to 0, then we are going to say player state equals state.idle. Okay, so hopefully that makes sense. If the velocity.x is equal to 0, player state is equal to state.idle. When we run the game, this won't work, but I'll show you why. I'm going to actually print velocity right here. You can do this as well if you want, so you can see how this works. Elif velocity.x is not equal to 0 and input.get is action just pressed, UI roll, or I'm just going to use down in this case. Then we're going to say player state equals state dot rolling. Now, LF velocity.x. So what I'm just going through is kind of the sequence of events that might happen in the game and the state that will respond to them. So LF, if it's not equal to 0, then we're going to say player state equals, wait, if it's not equal to 0, player state equals state dot run. Now you might think, well, won't it just set this to running? No, it won't, because we've got elifs here. So if this is true for a frame, then it will set this. And then in the next frame, or the next time it updates in the physics process, player state will be set to rolling, and it won't do this. And we won't change it back to idle or running until the roll animation finishes, which we'll do shortly. So then we've got another thing here. We want to see if they're falling or rolling or jumping. So LF, this is just going to be an override here. So we're going to be able to override the running or anything else by saying, by pushing the jump key. Is on floor, if is on floor, and player state not equal to state dot rolling. If they start rolling, rolling takes over. They can't interrupt that. Expected and in. All right. If input dot is action just pressed, UI. I'm going to use up for jump. It's kind of, I don't like up for jump, but it's easy now. Saves me rebinding keys. Velocity.y equals jump speed. So we're going to change that velocity.y to the jump speed, and player state equals state.jump. And then we can add an attack here, but I'm just going to comment it out for now. Add attack. Oops. So that's where we'll put the attack options there. And then lastly, we're going to tab back out so it's in line with this one. And we're going to have an if not is on floor. So if there is something that's going to override all of this. And if the player is not on the floor, then we're going to check whether they're falling or jumping. And this is what the code is going to look like for that. So I'm just going to paste it in here. Oops. If velocity.y is less than 0, player state equals state.jump. Did I put it as jump? Yep. Else, player state equals state.fall. So we've got this little state machine working here. We're updating the different states that the game can be in, and we're kind of locking off and blocking other actions. Now, the final thing is to get the movement done. Then I may as well just do the animation now, even though this video is going to be quite long. I'm just going to double check that my audio is recording. Good. And this video will be quite long, but that's okay. Velocity.y plus equals gravity multiplied by delta. So this is going to add the gravity to the scene. Velocity equals move and slide. Velocity, and then we need to tell it which direction is up so it can check whether it's actually on the floor. Now, I've seen a lot of tutorials, a lot of things online say that you should not use move and slide until after is on floor, because it updates the frame. It really doesn't matter, because it's going to update it here, and then you can use it in the next frame anyway, or the next update cycle. I'm not sure what the technical term is there, but I just call it frame. So it'll update here, and then when it gets back to the top, it doesn't reset it. It just changes the flag for is on floor. So it should be working. Let's hope that I don't get the glitch that I got while testing this. And then lastly, I'm going to print. Actually, I don't need to print the state. So this should all be working except for rolling. Rolling's not going to do anything. Now, if I run this, I'm going to, it's going to probably give me 100 errors. Let's just test this scene. I should be able to, what? Physics process, what have I done there? Invalid tag. Oh, I didn't put a tag up here. Okay, there's my character. Oh, he went over there somewhere. We'll just bring him back into the world, 2D. He's slid off the edge. Okay, I'll lock that there and move him over here. Okay, so I can run, I can jump, up jumps, down would roll. Actually, down did roll then. But there's no way to get out of the roll animation currently. So the rolling is work. The rolling state is working, but we've got no animation to play. So let's go ahead and add in a function that will update our animation. And we're going to do this right at the bottom after everything else. So we're going to update animation. I'm going to write a function up here. Func update animation. Now I'm going to take the code that I've already written for this and put this in, and then you can just kind of pause it. So the code looks like this. I may need to check these things to see that my animation plays the same. If velocity.x is less than 0, we're going to flip the sprite horizontally. But if it's greater than 0, we are not going to flip the sprite horizontally. We'll set it back to normal right facing. Then we're going to match the player state. If the state is .idle, we're going to play the idle. If the state is .running, we're going to play the running. If the state is .rolling, we're going to play rolling. State.jump, etc. State.fall, etc. With these though, what we need to do is change at some stage, change this rolling animation back to player state.idle. And I'm going to test it in here, but first of all, we should see that this works. I'm just going to check my animation names. So we've got idle, running, rolling, jump. I'm just going to change that to jump, and fall. So let's test these. Okay, the idle one's not working, but the jump's working, so up and down. Roll did work, but he just keeps rolling. So it looks like it's mostly working except for the idle animation. So let's see why idle would not be working. That's right, I was going to explain why idle wasn't going to be working. So you'll notice down here, print velocity. So let's go ahead and just move a little bit, and you'll see this down here. I printed out the velocity of the player. I'm going to change this collision shape to a rectangle and just see if it does any better. Probably not got that quite right. All right, so we've got the velocity there. That's working a bit better. The capsule, bit iffy with the 2D stuff. So if I move right, you'll see that this velocity is going way down, but it's still not actually equal to 0, even though it's printing out here. It's like a fraction of 1, and it will just keep on kind of approaching, because of that lerp, it will keep on approaching the 0 vector, but never actually reach it. Now, this may be an issue, and there may be a way to fix it by using move toward instead of lerp, and I'll have a look at that in a sec. But this was my little fix for it here. If negative 30 is less than or equal to velocity is less than or equal to 30, then I just said velocity.x equals 0. So anything less than 30 or anything greater than negative 30 and less than that. I don't actually know if this code works in Godot, so let's just test it. No, it doesn't, so I have to do it like this. And velocity.x is less than or equal to 30. So you'll see here that if I use 20, I think. Yep, there we go. Anything less and he doesn't accelerate fast enough to kind of get past that initial movement. But you'll see that it's now, he slows down, and at a certain point it does go to 0 and sets it back to the idle animation. Right, so that's working. Now we just need to make it so that he can stop sliding. Once he goes off the edge, it updates that, but we just make it so he stops sliding. And this is where a handy little piece of code named yield comes in. So we are going to yield, and what we're going to do is say, don't update or don't continue this bit of code here. Just remember it for a sec until we receive a signal back from the animation player that the animation player has finished. And then we're going to say state dot player underscore state equals state dot idle. We'll just change it back to that, because then in the next frame it's going to update this anyway. So this here is how it should work. So I should be able to slide, and then it continues. So I get that little slide animation happening. The slide animation goes a little bit too long, and it may be that the slide animation, rolling is what I called it. Oh yeah, see, it goes out to 1 second. So if I bump that down to 0.5, I could also have like a rolling speed, but in this case, he slides, works really well. Oh, I can't get up there. So that's it. We've got all the animations are working there. Now, in the next video, I will probably rewrite some of this stuff and see if I can change this from lerp to move towards. I think there is an option here called move towards, move toward. Move from toward to by the delta value, and it should return. It should work better. It should get down to 0, and I shouldn't need to do that little thing where I round it down to 0 if it's less than 20 or 30. I'll have a look at that. But another thing I want to do is add some other animations, such as the attack animation and a hanging animation. So actually hanging on the edge of something, which should be fairly simple. We just need a separate collision shape that's kind of above and that will hook onto the edge, and then we'll change if that's colliding with the ground and so on. Then we'll change the animation. So that'll be another thing that we look at in another video. But this video has been long enough, so I hope this has been helpful. Hope maybe it's a little bit different to some of the other Godot platform tutorials out there, in that it's kind of looking at a state machine, but the code here, I think it's pretty simple. I don't think I've made it overly complex. We've got the update animation. We've kind of separated the visual side of things from the physics side of things, which is what we should do, and kept it all fairly straightforward. Let me know if you enjoyed this video in the comments below.